Okay. Good morning to everybody, and it's a pleasure to introduce today Professor Cuihong Yan. Thank you very much for accepting our invitation. Okay, just a short presentation. Cuihong Yan is full professor at the Chinese Academy of Science, where she also obtained her PhD. Her main research areas are input-output analysis, economic forecasting, global value change, macroeconomic analysis, and policy research. She has applied input-output techniques, econometrics, and other quantitative models to the evaluation of global value change, grain security, environmental issues, and more recently to the global economic impact of the pandemic COVID and so on. She has published more than 80 articles in referred journals, including Economic System Research, Journal of Environmental Economics and Management, Nature, China Economic Review, Economic Modeling, and so on. And she has also written more than 60 policy reports for national and international institutions to inform governmental economic policies. She was vice president of the International Input-Output Association and currently is vice president of the Chinese Input-Output Society. Also, she's member, among others, of the editorial board of the Journal of System Science and Complexity, Journal of Economic Structures, and Economic System Research. Today, Cuihong is here to discuss, to share with us one of her current and highly relevant research lines on the role of the firm size on value-added generation and CO2 emissions in China. So thank you very much for your kind willingness to be here, and the floor is yours.
Thank you very much, Rosa, and it's my great pleasure to be here to introduce the work for the firm size level. And thank you very much, Rosa, for your kind invitation, and also thank Yolanda and York for their kind arrangement. Thank you very much. It's my great pleasure to be here to introduce the work. And could you see my screen?
Yes, but can you put him in full mode right now? Great.
Yeah, it's okay. Yeah. Actually, this is joint work with Zhang Junrong, who was my PhD candidate. She just graduated and now work in the University of International Business and Economics. Actually, this is one major part of her PhD thesis. We just talk about the performance in value-added generation and CO2 emission by firm size, in particular, in large, medium, and small firms here in China, our classification. And this is contents. Firstly, the background, and then the layout of the IO table by firm size, and the data sources and the processing, and some of the estimation of the major matrices, and finally some empirical results. Actually, now SMEs are mainly talk about not only in China but also worldwide. For OECD and World Bank, they have many researches into the performance of some small and medium-sized enterprises. Here in China, we have several numbers. That is 5, 6, 7, 8, 9. Actually, the SMEs has already play a very important role in China's economy. 5 is 50% of the taxes, and 60% of GDP, 70% of technological innovation, and also 80% of urban employment, and 90% of total firm numbers in China. Here, the several pie is the data from the 2018 economic census, we could see that the SMEs actually play very important role in China's economy in terms of employees and total assets and also total income. But this is also, when we look at the numbers, in particular the employees, especially from last year, we could see that the SME was heavily impacted by the pandemic. So, but for this data, we could see that the SME is the largest contributor in employment generation in China, and also it consists of almost almost 3/4, actually the 75% of the total. Thus, it's become more focused in China now. But actually, when we look at the performance by different firms, we could say that the large firms, although the small firms, small and medium-sized firms, contribute in employment generation, but in terms of exports and industrial sales output, the large enterprises still dominate. So we could see that from this aspect is that their performance is very different in terms of different indexes. This is from macro level, but unfortunately, when we talk about in our input-output framework, the input structure by different size, by different from types, in particular in terms of the size, we have to know systematic statistical data. But we could see also some data. This is some survey data in terms of their CO2 emission coefficient, and also the input structure. Zero is the data is not so much. There's not so much on the data, but still we can still find some facts. So this is a survey data from for the cocoa making industry in Shanxi province. This is a major cocoa making provinces in China. That they have a survey on 10 firms. We could see that in terms of the CO2 coefficient per ton of coke, the firms are very different. When I asked the local people, they said that actually for the large firms, usually they have lower CO2 coefficient, emission coefficient. So this is the major motivation why we tried to make a distinction in the IO table into large, medium, and small sized enterprises. Actually, in terms of the China's trade and the carbon emissions, there's a lot of papers studied on this issue. In particular, in national level and industrial level, but for firm level, it's not too much. So this is the one of the motivation. And for the differences in their production structure and technological level, import and export trade, and also their energy consumption and the energy intensity and the carbon emissions, in terms of the size, it's very different. Actually, for the firms by ownership and for the trade by trade regime, there's a lot of research, not only in our team but also the team from the United States and also from Butter's team group. There's a lot of literature on firm ownership and also the foreign trade model. In recent years, there are some researches by firm size like Tong. They published a paper in Applied Energy in terms of the CO2 emission by firm size as well as by the firm ownership. That is some state-owned enterprises and foreign-owned enterprises. But still, the literature here for firm size, there's not too much literature on this issue. So what our question is that what are the respective roles of different sized firms in China's foreign trade, and what's their roles in the CO2 emission, and are there other significant differences in the value added and trade embodied carbon emission among these different types. In this respect, and we constructed the extended table that distinguish the production of large, medium, and small-sized enterprises. Firstly, we started from the year of 2012, and later on, we also constructed the table for 2007. And in this presentation, I mainly focus on the economic gains and the environmental costs by exports by firm size. This is the layout of the table. This is we just make a distinction of the one domestic delivery matrix into 9, because we just make a distinction between large enterprise and medium enterprises and S enterprise and small enterprises. We abbreviate SA table as LMS model. And the data next part is the data sources. Actually, this is a very time-consuming work to make a distinction between the firm size, different firm size. First table is that we get from the National Bureau of Statistics, and also the sum of the parts are jointly done by our two teams, National Bureau of Statistics and also the Chinese Academy of Science team. They are input out the table capturing a domestic delivery and imported delivery. Why I just emphasize that, because before we do not make a distinction in the intermediate delivery. We have only one matrix, but actually we should make distinction between domestic delivery and also imported intermediate inputs. This is one type of data. Another data is the firm level data. The firm level data, there's two data sets. One data set is by the National Bureau of Statistics. This is our major data sources when make a distinction between large, medium, and small-sized firms. That is Chinese Annual Survey of Industrial Firms. They covered 300,000 firms, and they account for almost 95% of the total industrial output. So it's a very good representation of the full coverage data. And this is one firm level data. Another is that the China Custom Trade Statistics. Unfortunately, the two systems, they have different costs. They have different costs in terms for each firms. So we have to match the two data sets. Other statistics, like for example, the yearbooks and also the economic census yearbook. We have 5 years. We have economic census every 5 years. They have more disaggregated data by industry. So this is another data sources. And for the classification of large, medium, and small sized firms, actually it's different across the countries. Here in China we have two thresholds. The one is employment. Like for example, for large firms, they have more than 1,000 persons, the employees, and at the same time, their sales revenue is larger than 400 million renminbi. And for mediums, it's in between. The employee is in between 300 and 1,000. And the sales revenue in between 20 million and 400 million, and the rest are small enterprises, small-sized enterprises. So, but due to data availability, in our conventional table, we have 139 sectors in the year of 2012. Due to data availability, we made some aggregation. We aggregate the sectors into 29 sectors, of which 24 are industrial sectors, including mining, the mining sectors from 2 to 5, and manufacturing from 6 to 21. And others is scrap and waste, and some electricity, and also the gas and water, and some construction, and some other service sectors. So we have 29 sectors. And the data, we use the conventional table and also form level data to finally obtain the table from size. And next, I will briefly introduce the estimation of major parts or major metrics. We have to estimate the total indicator metrics, like, for example, the input and output and value added, exports, and domestic final use, each metrics, and also the import metrics. Domestic delivery flow metrics. After we estimate the import metrics, that we can obtain the domestic intermediate flow metrics, but based on some proportionality assumption. And also we have to estimate the carbon emission metrics. Firstly, the total indicator metrics, like, for example, the output, we mainly focus based on the industrial enterprise database. As I just mentioned, that we have not full coverage, but almost a very high share, like, for example, 95% of the total. So we just use it as a full coverage data. Obtain the ratio. Firstly, we obtain the ratio from size of total output, value added, and export from the industrial enterprise database. And use it as a full coverage. Use it into the IO table. And based on the IO table, we can make a distinction of total output metrics by different from size, and similarly value added metrics and export metrics. The share is what are obtained from the industrial enterprise database, because there we can have a clear distinction between a large, small, and a large, medium, and small from size according to the classification standard of the National Bureau of Statistics. This is the second is a domestic final demand metrics. Here is an assumption is that we assume the final demand ratio by firm size equal to their ratio by output of total output by different firm size. So this is the estimation method of domestic final demand metrics. Oops. Okay. Yeah. Next is the import metrics. We already have import metrics in the conventional table, but it's in total. And the first step, we have to match the firm level data from the NBS and the custom census data from the customs to obtain the metrics of different sized firms. Actually, now here in this match, it's not full coverage. We matched about half. The matched output is 43%. We have tried our best, because we use very detailed information into data sets to match the same enterprises. It's very time consuming, but we try our best to match the two data sets, and the matched data account for 46% in terms of export value, total export value. So we use this metrics into the table. We assume that the import matrix in the table has the same structure with the matched data, and based on which we can obtain, you know, the IML, the large enterprises, the import matrix of large enterprises, and also IMM, the import matrix of medium-sized enterprises, and similarly for smalls. For the intermediate flow matrix, because we already have the total, the total matrix by firm size and also the imported inputs, and we can get the total for domestic flow matrix. And we use two kinds of coefficients to estimate the domestic intermediate flow matrix. From the supply side, that is vertically, we assume that the share of the intermediate inputs by G1 is a group of large, medium, and small groups in sector I equals the share of the sector I in their corresponding types in terms of the gross output. Actually, the share of the gross output. This is from the supply side. From use side, that is horizontally, we assume that the type G2's share of domestic intermediate inputs in sector J equals their shares of intermediate inputs in total domestic intermediate inputs we already have demanded by the same sector. So the intermediate flow matrix can be calculated as the following formula. And up to now, we have obtained all the flow metrics, including domestic final demand and imported input, and also the domestic delivery input metrics. But still, there's another step we have to make balanced. Then we use the Ross method to make it into a balanced table. So this is a very rough procedure to make the table. Actually, it's a lot of work for each part. And also the carbon emission metrics. Here we have an when we allocate the emissions across the different types of firms, actually we select 5 energy sectors. We just use their dependence on the intermediate inputs from energy sector, the 5 energy sectors. The 5 energy sectors are coal mining and processing, and crude petroleum and natural gas extraction, and petroleum process, electricity, and also gas production and supply. And the CEJ is a carbon emission matrix in the conventional table without distinction of firm size, and multiply their weights, to obtain the carbon emission matrix, which we only capture their inputs from energy sectors. Okay, I think for our IO people, these are very for these formulas we are very familiar with formulas. The contribution of this model is a compilation of the table actually. So we can capture calculate the domestic value added by different types of firms, and also the CO2 emission imported in exports by different size firms. This is the basic description of the main indicators in the table. We could say that in the first row, is a performance of large firms. It consists of 33% of value added, and 37% of automotive share, and almost a half, 48% of the export share, and it accounts for 38% 39 of the total CO2 emission. And the second row is medium and the third row is small firm sized. But when we look at each indicator, like for example, for the value added share, the large firms account for almost 1/3, but for the exports there, it account for almost a half. And so they have different performance in terms of different indicators. This is a basic description. And when we look at their efficiency, like for example, the first three columns is value added generated by unit exports. We could see that large firms usually get lower value added per export per unit of exports, but for the small sized firms, it's the highest. Actually, it's related to many factors. Like for example, I could show in later slides. For example, the large firms mainly focus on something like electricity equipment manufacturing and electronic equipment manufacturing, and some of them are export oriented and some of them are processing exports. But for small firms, most a very high share of small firms located in labor intensive sectors, like for example clothes and textile industries, for example, etc. But for the CO2 emissions, it shows a very similar pattern in terms of the value added generation. The large firms are more environmentally friendly than medium-sized firms and also small-sized firms in terms of their CO2 emission per unit of exports. So this is also the correlation, the linkage between different firms. We could see that this number is a total intermediate inputs of large firms. We could say that it's 31% of its total intermediate inputs come from large firms. And let's see. Let's see, large firms. Oh yes, almost 29% come from small firm size, and 21% come from imported intermediate inputs. And the right hand column is the import independence by different firms. So we could see that the large firms depend more on imported intermediate inputs, and the small ones, the small sized firms, is less dependent on imported inputs. Actually, this is is closely related to their industries in different firms. Large firms focus on electronic equipment and also electricity equipment, this kind of industries. Yeah, this is by sector, and this is CO2, the value added generation and the CO2 emissions by sector. Okay, now this is a share of as I just mentioned, that the large firms, they are by industrial share, they mainly focus on electric equipment, not electricity, electric equipment and electronic and telecommunication equipment. But in terms of the medium-sized and the small-sized firms, they mainly focus on it's more how to say distributed into more industries, but where the leather and firms and wearing apparel and also chemical products. Some of them are labor-intensive products. Yes, this is for small firms and medium-sized firms. Sorry. Yeah, these slides again by sectors, and when we look at the value added generated per unit of exports and also the CO2 emission per unit of exports by sectors, we could see the very different performance by firm size. The large firms usually they have lower value added per unit of exports compared with the medium size and small firm sized small sized firms, in particular in the more concentrated sectors, like for example electric equipment and electronic equipment. It's much lower than medium and small firms. Okay, this is a research we did last year for the to estimate the impact of COVID-19 on jobs. This is the data of 2018. We could see that actually for the small firms and medium firms, they recruit a lot of employees in construction and wholesale and retail trade. And last year, in particular, wholesale and retail trade last year was the most heavily impacted sectors in China. Because we have in particular for the first 3 months we locked down for some labor intensive sectors, because we close the restaurants, we close the hotels, we close the accommodation, the creation facilities. So they were very heavily impacted, and this is one application of the table by firm size. And this is the impact, the negative impacts of COVID-19 on jobs. In the first several months, the unemployment rate is much higher than the previous years, and of course it's much higher than this year. But actually most of the unemployment is focused on wholesale and retail trade, and also construction and other, like for creation of facilities, and also hotels, and also restaurants, etc. And so small and medium-sized employees and self-employed households were impacted more seriously, and their employment last year their employment demand decreased by about 7.4 million. Last year, we made a very rough estimation based on the demand-driven model. We firstly estimate the decrease of consumption, in particular in the wholesale and retail trade, and then accommodation and catering, and also tourism, and also some of the decrease of the investment. But actually, for some industries, the investment increase, like for example, for the medical related sectors. And then, so last year we made a comprehensive estimation of the impact by COVID-19, not only on jobs but also on the value-added generation. So some of the conclusions, and it's some of the conclusions I have just mentioned before in previous slides. when we look at the regions, when we look at the numbers, we would consider why the hidden regions may be different in the export structure and also the import intensity of intermediate inputs across different sized firms. Like for example, I just have mentioned the large enterprises mainly export the so-called high-tech electric equipment and some sophisticated products. But the medium and small enterprises concentrated more on labor-intensive and resource-intensive products. And in terms of the import dependence, large-sized firms is more heavily dependent on imported inputs because they export more high-tech related products. Yeah, so Rosa, I think this is all for my presentation, and I would like to very much your comments and suggestions. Thank you very much.
Thank you very much to you for your presentation. Very nice presentation. Okay. We have now time for questions, for comments. You can raise your hands in the Teams if you want. Jorge, no? Yes, Jorge, the first one.
Yes. Hello.
Hello.
Hi, Cuihong.
Hi.
Sorry, I came late because I have a medical consultation, so I missed the beginning of your presentation. But congratulations
Thank you
for the rest of it. I only have a short question for you. I think it's also very important to think about the firm's ownerships because some of those large firms are going to be multinationals. So do you have any exploration in this case, or can you tell us something about this? Thank you, Cuihong.
Yeah, thank you. Actually, I'm not so sure how to pronounce your name. Your sorry.
You can say George. You can say George in English.
Yeah. Actually, a very good suggestion. We also do some work of the distinction by ownership. But you're right. For the large, medium, and we can make it further distinction between by ownership. So I think that's very important.
Okay, thank you.
Okay, Bart.
Thank you, Cuihong, thank you for the nice presentation, and I think you clearly showed that constructing this table was actually a lot of work. So quite often after having constructed data like this, I think it's important to also focus on how plausible the results are or how plausible the data are. So when when you explained what type of data you could use next to the national, more or less traditional input-output table for China, it became clear to me that you have a lot of information on, let's say, the primary inputs block by firm size. So imports, value added, gross output. You also have information on the part of the final demand block. You have exports by firm size. But if I understood correctly, you don't have any information by firm size on intermediate inputs. You had to apply strong proportionality assumptions simply because of lack of data. Now, I'm interested in knowing whether you try to figure out whether the difference that you find within industries between the large firms and the small firms, for example, are comparable to what economic studies found. So there's a lot of, maybe not for China, although maybe people like Lauren Brand have done research like this. So it is well known that small firms produce differently from large firms. So can some of these stylized facts from microeconomic studies be well, are they reflected in your macroeconomic indicators as well, just in intermediate input use? Do you see anything like economies of scale, for example, in some industries, or not at all? Or that's the type of questions I'm interested in.
Yeah, actually, I think Bart raised a very insightful questions. We tried to, firstly, in the starting stage, we tried to address the issue because of because small firms and medium firms, they have very different production production function. But it's hard to capture them. But I think it's very good. It's a very good question. It's a very good issue. And I will ask Junrong, and I will discuss with Junrong how we could use the theory of microeconomics to use how to integrate into the estimate of the intermediate delivery metrics. I think it's very, very important. But here in this table, we mainly use the data, not fully consider the theory of microeconomics, especially the scale of different firms, of a scale effect of different firms.
Yeah. Yeah, I see. But at first, before integrating insights from microeconomics into the data construction process, you could, in principle, first check whether some of the basic empirical stylized facts from applied microeconomic research are reflected in your data. And if so, then this would give more credibility to the table that you constructed. And because I think it might be a bit risky if you would use theoretical insights into data construction. That I don't know if that would be the best way forward. But just checking whether those stylized facts are reflected in your data might be helpful.
Yeah. Thank you very much, Bart. Jerome, do you have some response with Bart's question and suggestion?
Hi, Bart. Thank you so much for your suggestions. I think it's a very good suggestion for the input-output construction, because I agree with you that there are many differences between the medium-sized firms and small-sized firms. There are many differences on the intermediate input structure. But now we don't have more information about the intermediate structure and production structure, so we can just use some assumptions to construct the IO table. I think you gave us a very good suggestion, and we can do some further research on this question. Thank you, Bart.
Thank you. Mateo?
Hi, Rosa. Thank you. Hi, Jan. Hi, Sang.
Hi.
Thank you very much for the presentation. Yeah, it was very interesting. Here we are researching on multinationals and the carbon footprint of multinationals, so it's very interesting for us. I got a question for you. You guys found that big companies are more carbon intensive than medium and small companies in some sectors. What could you tell us about how Chinese climate policies are addressing this differentiation in the carbon intensities of companies by size? Was I clear?
Yeah, I
Okay.
understand your question. Yes, as I understand, I don't think they have very clear policy from sizes. So only industries, not only mainly industries, they have different policies in carbon carbon emission reduction. But I don't think they have very clear policies from sizes, mainly focus on industries.
Okay, thank you. We hope your work helped helps to address that problem, right?
Thank you. Yeah.
Sophia?
Yes. Yes, me. Many thanks for the presentation. It was really nice, really nice. I have two questions. The first questions will be maybe related to Bart question. Is it in what sense your results are showing the issue that larger firms are more environmentally oriented? I mean, they can apply more circular economy policies such as recycling, waste, etc. So I don't know in what extent your results can also show in this. And the second question is how you would suggest will be the way for improving the emissions of the smaller enterprises, because maybe it could be related with the technology they use that may be older and it's more pollutant, sorry. I don't know if you understand.
I'm sorry, I didn't.
Yeah, the second question
clearly
is that,
the second question. The first one I understand. Yeah. Could you repeat the second question?
Yeah, the second question is that if you have any suggestion for smaller companies to improve the way they emit it. I mean, because I think that there is that is BA, so can be explained also by the technology they use, because the technology can be older and can be more pollutant than the technology that can use the larger or the medium larger firms. I don't know if I explain myself properly.
Yeah, actually, some of the results are not consistent with our with our observation. You mean that for some of the firms they are more pollutant than other kinds of firms, but it's not so consistent. When we look at the results, is that not necessarily the small firms are more pollutant, are more pollutant than the medium size and also and the large firms, large sized firms, because they focus on very different industries. If we when we look at into a little bit detail into industries, we may have more policy implications. I'm not so sure whether I capture your question. Yeah. The first question and the comment. Thank you very much. Actually, we will discuss actually how to capture the different production function by different size of firms, not only through the data.
Okay, thank you very much.
Yeah, thank you.
Okay. I have also a question for you that is about more or less the share or the participation of these three types of industries in the global carbon footprints. I mean, to what extent this relationship, this share of responsibilities in the emission are similar or are different if we have in mind the global footprint of China.
The global footprint?
Yes.
Yeah.
The carbon footprint. I mean, you are dealing with the direct emission, with the Chinese emission, and you say that this is the different behavior of the industries is related with the dependence on foreign imports. Okay, but to what extent these differences are in a different sense in case that you consider the pollution of the imported inputs, for instance?
Oh, I understand. Yeah.
Okay.
Actually, there is some data in our table that we could see that the large enterprises depend more on import than medium and small sized firms. But I think you raised a very good question. Like, for example, if we could make a further research into import by industries and by their source, like from which country, and we could capture the carbon emission. The carbon, not carbon emission. Yeah, the carbon emission.
The carbon.
The China
yes, the carbon
contribute to
yes,
the world. Yeah.
Yeah, because perhaps one issue is that the big industries are delocating the inputs going to other countries or something like that. So we are not capturing the full carbon footprint, the full responsibility. I don't know.
Yeah, right. But for the single table, it's not so
yes.
easy.
No.
So we have to use word table
to
capture that. Yeah.
Okay.
But yeah, it's a very good point, I think.
Okay, Bart, again,
Bart?
You have your hand raised?
Yeah, if I'm allowed to ask another question, then I would like to. So it's a little bit of a follow-up to my previous question, but because I understand that just asking for more detail on on differences in intermediate input structures between large, medium, and small firms may be quite a big ask. But given that you focus on emissions and on let's say the environment, would it be possible somehow to know more specifically about the expenditures on energy by each of these firms? So leaving all the other intermediate input requirements as similar as possible, would it be somehow possible using energy use data to make a further distinction between large, medium, and small firms? Because, well, again, electricity use is, of course, a very, very important determinant of this.
Right.
Especially if a lot of electricity is generated in coal-fired plants, like in China. So, would there be any statistics on this that you could use, specifically on energy use?
On energy use, we may have more data. Like, for example, for the electricity generation, most of the electricity are generated by large firms. For the small firms, it's too much for them to how to say. And so previously we have some small firms for electricity. Like, for example, for electric generation, it's a very big energy consumer. But later on, I think most of the small firms have been demolished because
this is about producers of electricity, but my question is more about the users of electricity. So do you have information about, well, for example, firms in the machinery industry, how much energy they use, and if this is proportionally higher for large firms than for small firms, or the other way around?
Yeah, we have in total, but Cuihong, please check. Do we have the data by different size firms of the electricity consumption by physical unit?
Oh, sorry, but we don't have the data to classify the different firm size of the energy use, energy consumption. We can't classification the different firms' energy consumption. We don't have this kind of data.
Okay, but you don't have them currently, but they're also cannot be obtained somehow from other data source. I don't know about, well, whether this is data, other type of data collected by NBS or by some other public agency.
Okay, thank you.
Yeah. For the intermediate inputs, except the years for benchmark for the very big IO special survey, like, for example, the years ending with 2 and 7, we do not have the input data. For other years, we do not have. But for the years ending with 2 and 7, we have the input data. We have the input data for most of the industries, but not full coverage. But it's okay. It's still it's okay. General, we may try with NBS stuff whether we can have some data for the, like for example for 2017, the benchmark years for the IO compilation. Probably we may have some data in terms of Butter's suggestion.
Yeah.
Yeah. For some certain years.
Mm-hmm.
Okay.
Thank you, Bart.
Yep.
Yeah.
Welcome.
Thank you. Any other question?
Sorry. One comment here, Jorge.
Okay.
George. I think this is one of the most challenges we have if we are dealing with differentiation between the firms of the size of the firms, and also if we are dealing with differentiation between multinationals or domestic firms. Also, if you use the information from the OECD tables that they are differentiating between these different technologies, you have to try to do something different if you want to have different emissions intensities. And this is one of the challenges we have now. Now we have the information, the disaggregated information, but now the next step is to improve the results in terms of carbon emissions. So I think this is one of the challenges we have.
Yeah. Thank you. Yeah.
Okay. Any other question? Any other comment? Okay, so we can stop here. Thank you again for your nice presentation today and the discussion, and to close with your talk this season of webinars of the SHAIO. Thank you to all the participants to be here. And let me just in a minute to announce that the next, the 9th SHAIO conference on input-output analysis, this is coming. This conference will be held next September in Aveiro in Portugal. The conference will be held on 22 and 23 of September, and the input-output school the day before on 21st of September. We have an excellent local committee led by Professor João Pedro Ferreira and his team at the Universities of Aveiro and Coimbra. And they and the association, we are already working hard to prepare a very nice conference, and we are sure that this will be an opportunity to meet again a large part of the SHAIO community and friends. So the information is already available at the webpage, and we invite you to enter and to visit, and we keep you informed. And finally, thank you very much for your participation. This is the last SHAIO webinar this season, this year. We think that this has been a success in terms of participation. We have had top-level speakers from all over the world, and we will back next year with renewed enthusiasm, and we hope to see you all. So happy end of the year and even better start of the next year. See you soon.
Yeah. Thank you. Thank you.
Thank
you very much for your input. Thank you. Thank you.
Thank you, Rosa.
Bye-bye.
Bye-bye.
Thank you, Rosa. Thank you, Bart. Thank you. Bye-bye. New York. Thank you. Bye-bye.
Bye. Thank you.
Thank you.
Okay.
Bye-bye.
Thank you. Thank you.
Thank you. Yeah, thank you.
Very good presentation. Yes.
Thanks.
Enjoy.
Yeah. Thank you.
Bye.
Hi, Yolanda. Bye-bye.
Bye-bye. Bye-bye.
Bye-bye.
Thank you, all of you.
Close, Yolanda?
Yeah, I close, okay? See you.
Okay. See you.
Bye-bye.
Thank you very much.
Bye. Thank you very much.